Well, hello. I have recorded two videos for Unit 1 review. Each of them is about 15 minutes. The questions on these two videos are coming from Unit 1 review document, which was placed at the bottom of Unit 1 folder. So remember one thing, these are just guiding questions. Test 1 questions are not limited with those, but I thought that this will be the crucial and the key ones that you really need to pay attention to. So I'm going to take myself off from the camera and I will talk. Okay, so the first question here is solving variables on both sides. Okay, let's see, let's get our pen. So first we need to distribute, and as we're distributing here, always consider the negative. We're distributing, so let's rewrite it. 8 minus 4x plus 12 equals negative 40 minus 16x. Okay, it's too big. Let's see. And here we go. So combine like terms here. So 8 plus 12, 20. So negative 4x plus 20 here. Negative 16x minus 40. I always would like to see x as the first term. That's what I write it down. Next line will be, so I'm going to add 16x here, negative 20 there. So then that will be 12x minus 6. See? And we divide both sides with 12, and x will be equal to negative 5. Right, so solving variables on both sides. Be careful as you are distributing negative 8 over 5. That's a very common mistake. On the second line, get variables on one side, get numbers constant on one side, and solve the equation. So that was question 1. Let's see. So this is solving a quadratic equation. Again, when we're solving a quadratic equation, we would like to see 0 on this side, preferably on the right hand side. So I'm going to negative 3x minus 4, negative 3x minus 4 on both sides. That will be 5x squared minus 21x minus 54 equals 0. Now, your hurdle here will be factoring, and you're not alone. So I'm gonna do very quick way that I do it, but sadly we won't teach the factoring in this course. That is a prerequisite, so I'm just gonna do it by once. How do I do it? So I'm looking for the multiples of 5x squared. Luckily 5x is a prime number, 5x and x. Think about the multiples are 54. So I place them in a way that when I multiply them, so one of them should be one of them should be negative 54. Which one should I give the negative? I'm going to try to give this one. So 9 times negative 6 is negative 54. When I cross multiply 5x, negative 6, negative 30x, 9x, x times 9, negative 30x plus 9x is negative 21. So that will work. So then I can write 5x plus 4, thinking about like a line there, if you will. So I look at the top of this line, 5x plus 9, and bottom, that is x minus 6, that is equal to 0. So 0 product rule, then 5x plus 9 equals 0. 1 will be negative 9 over 5. X plus 6 equal to 0. The other one is 6. So then I'm going to say that, okay, one root will be x equals negative 9 over 5. The other one will be equal to 6. This was solving quadratic equations. I'm not doing all of them again. The solution key is posted already. I'm just doing some of them. That will be really must, if you will. All right, so this one we're solving a rational equation. So for the rational equation, the idea is isolate the term. All right, so for us to be able to do that, okay, so what do I need to do? I need to get rid of that -5. So I'm going to rewrite here 12 minus 5, 7, and we are going to be left with here 9 minus 8x. Now I can square, take the square of both sides. So that is going to give me 7 squared is 49. Square root will lift off. Then we're solving a regular equation, if you will. So then -9 on both sides. So then we're going to have 40 equals -8x. And if we divide both sides with -8, then x will be equal to -5. Now, this is one thing that you need to be careful, isolating the radical before taking the square. The other thing that we expect you to do, this may not suffice. This may not validate. So whatever you end up with, 1 or 2 solution, you have to check. That is part of the solution, right? Because we're making a huge assumption here. If the numbers are equal, their squares should be equal, right? So this is the assumption here. If this equation holds, then their squares will be equal. Well, that's not the case always, right? So if you think about, for instance, 2 is equal to, not equal to -2, but if we take the squares of both sides, that will give us 4. So that's why we're checking it, if it makes sense. Where are we going to check that? In the original equation. So I'm going to write it down. 12 equal 5 plus square root of 9 minus 8 times -5. Is this equation hold? Is it equal? Let's see. So that will be -40. Right, so let's write it here. Okay, so square root of -5, so +40. Sorry, that's what I was thinking. So this is +40 plus 9, 49. I have 49. Now, when you're taking the square root of 49, you only think about 7. That's the other thing. Only. Think about that. Because the reason is this is a square root function, and domain of square root is x is greater than equal to 0. So we need to think that. Okay, square root of 49 is 7. 7 plus 5 is 12. Checks. So yes, x equals -5 will be the solution. I wouldn't worry about the cube root function for the test. That's another hint for now. All right, let's continue. Let's see. All right, so I choose this one also to be done. So this is solving rational equations. So there is factoring here, but factoring is kind of hidden, so you don't need to do much. If you have something like that given, so this portions should be the factors of those. So this is what I mean. So 2 over x plus 6 equals 4 over x plus 1. Then we should be able to write this guy as the factors of x plus 6, x plus 1. Right? So x over x plus 4 divided by x plus 6 times x plus 1. All right. So How do we add the rational numbers? Get them on the common denominator. So I need to multiply this x plus 1, this one x plus 6. So then I will write 2 times x plus 1 equals 4 times x plus 6 plus x plus 4. So I'm not writing the denominator, I'm just putting the word d. Why? Because if I do have 2 rationals equal to each other, 2 rational functions, a over 5, b over, then I can say that they're equal. Their denominators are equal, so the numerators should be equal. However, I need to keep one thing in mind. Because the denominator contains x plus 6 and x plus 1, so if I end up with -6 or -1, that I cannot include as a solution, because those values are going to make the denominator equal to 0. So I'm going to continue from this point, this black line, and forward with the numerator part. So then I need to distribute that, 2x plus 2, that will be distribute that, 4x plus 24 plus x plus 4. All right, combine like terms, 2x plus 2, there's nothing to combine here. Combine like terms there, so that will be 5x plus 28. And then collect terms on one side, collect variables on one side, so -2, -2, -5x, -5x, so then we will have -3x here. This will be gone, this will be gone, so that will be equal to 26. X will be equal to -26 over 3. Okay, I'm checking with my denominator restriction here. That's fine, so this is the solution. Right, I'm gonna solve one more questions on this video because we're going on the 12th minute mark. Let's see what we have. Okay, let's see. Yeah, so solving absolute value equations. So when we're solving an absolute value, same as a rational equation, right? So if we go back up, this one, we isolate the radical term. Now we need to isolate the absolute value term. They're very similar, they're same kind, they have an object, we call it. So isolate this term. So we don't want to even see this 5 here. That's what isolate means. Okay, so hold on a second. Were we solving this one? I think I skipped one. All right, let's see. So I think I want to solve this one first. Yeah, same thing. So we need to isolate this one. Okay, so what do we do for that? We add 3. So that will be 3x plus 1 equals 21. And then we divide it by 3, both sides, just because of this 3 here. So we should not see anything, just an absolute value. Then that will become this will become 3x plus 1 equals 7, still an absolute value. Now, what does that mean? It means that 3x plus 1 equals 7, or 3x plus 1 equals -7. Now we can solve it. So subtract 1, subtract 1, subtract 1, subtract 1. That will be 3x equals 6. X will be equal to 2. 3x will be equal to -8. X will be equal to -8 over 3. So we have 1, 2 solutions, right? So this is an absolute value, solving an absolute value. So I want to mention one thing about it. For instance, if I have an equation like this, let's assume negative 3, oops,